Hi, this is Mrs. Grizafi. We're on 11.03 for geometry today. We're talking about cross sections and rotating two-dimensional figures to create three-dimensional figures. I know it sounds really cool, and it is. So what is a cross section? A cross section is when you take the intersection of a plane and a three-dimensional figure, and you get a two-dimensional figure. So the cross section will be two-dimensional. So it's like taking a slice out of a three-dimensional figure. So these, they kind of traced it for you here. So they're a little bit easier to see than when I just tell you what it is, which is what sometimes the Regents questions will do. So here, the first one, we have a pyramid. And we're slicing this green plane right here is slicing. It's parallel to the base. Now the base here looks like it could be a rectangle or a square. And since we don't know it's a square, let me make this blue, then we're going to assume that it's a rectangle. So if I sliced the top of that pyramid off, I want to know what shape would I see on the top of that 3D figure. So I sliced it where this green is. So I took a knife and I just sliced it right off. Think of it usually when we're in school, I have you guys make some of these using Play-Doh and then take a knife and do the cross section that way. So imagine that you formed this pyramid out of Play-Doh, and then you took a knife and you just parallel to the base and parallel to the table, you sliced off the top of the pyramid. What shape would you see on either the flat surface on the two pieces that are left? And you should see a rectangle there. So like this piece right here, where you would see if you took that off, that's a rectangle. So very visual here. Okay, if it had been a square, then we would say that it would end up being a square as well. All right, so this one we take a pyramid and we're gonna slice it perpendicular to the base. So if we do that, we're creating a triangle right here. And that's only gonna be if it passes through that apex, the top of the pyramid. And then this one, kind of interesting, we are not passing through the apex. We're going perpendicular to the base, but we're slicing off a part after the apex. So that's going to create there a trapezoid. And you can kind of see in red what shape you've made there. But unfortunately, you're not always going to see that. Let's look at if we take the cross section of a prism. So this one is a rectangular prism. Remember, to be a prism, you have to have two congruent parallel bases. So we see here we have two congruent parallel bases. They're both rectangles. They look maybe like a square, but in this case, we're going to assume they're rectangle because it doesn't say. And we're slicing off like kind of just right through the middle. We're parallel to the base of this prism. So again, this looks like it's going to be a rectangle. If the base, it was specified that all these sides were the same, then we could say it was going to be a square, but we don't know enough information. Here, we're slicing off perpendicular to the base. Again, that will still be a rectangle. And then this one is a triangular prism because your two congruent bases, parallel bases, are both triangles. So here we're slicing, we would slice straight down, so perpendicular to the base, and that would create another triangle. And you can see that shaded right there in blue. So take a minute, pause the video, especially when they're traced on, they're a little bit easier, but really try to visualize what the shape is, the 3D figure, so the next one for the cube, and visualize slicing off where that dotted red line is, and visualize what two-dimensional figure you would see once you took those two pieces apart from each other. Okay, so I'll give you, pause it, and then I'll go over those after. Okay, so since this is a cube, all four sides are the same. So when we slice off at that red dotted line, you would end up with a square on either side. Here, if we slice perpendicular to the base and straight down through here, we would end up with a rectangle. Now that one's tricky because a lot of you might be thinking that it's a triangle, because when you slice it, you will see the triangle right here. So it's actually, you're slicing off a triangular prism when you're taking off that one corner of the cube. But we're looking at what is the shape on the two sides that you're removing. So this place where you actually sliced it, and that's going to be the rectangle. And then this last one here, you're slicing off just the corner. So you're going in at a diagonal and slicing off that entire corner, which will create a triangle for this one. So different from that last one, because the last one we're going straight down. This one would be perpendicular to the base, where this one you're going diagonally, you're just cutting off the corner. All right, it's cross section of that should say of a cone, not a pyramid. Pause it, see if you can come up with what those 2D figures will be. All right, so the first one, we're going diagonal, and you can see here, you started to make an ellipse, but it's going to be flat on the top because it's actually chopping it right from the base. So this one is a parabola. This one, if you go parallel to the base, this one's going to be a circle. And this one, we're going diagonal. That one's going to create an ellipse. And again, we're talking about the cross section of a cylinder. Pause the video, see if you can come up with them, and then check back here. So the first one, we're going perpendicular to the base. Our base is a circle. This one actually creates a rectangle. Here we're going parallel to the base. So anytime you go parallel to the base of a cylinder, you'll end up with a circle. And this one, we're going diagonal from this corner to this corner. So you're actually going to create an ellipse. So it'll be rounded on both sides. Kind of cool, but also a lot of these are very hard to wrap your mind around. It's easy, right? It may be easy right now to see it because you can see that picture drawn. So your mind might be saying what you see it in the dotted lines, but it's hard to visualize it without that picture there. And the last one is a sphere. And here, if we slice off, here we're parallel to our great circle. This is called, which is the widest part of your sphere. And this one would be a circle. And what's kind of neat about the sphere, makes it easy. Any cross section that you take of a sphere is always going to be a circle. All right, so we're going to talk about something else. This is still hard to visualize, but I think these are maybe a little bit more concrete for some students. So it says, determine the shape of the 3D figure generated by rotating the 2D shape about the stated axis of rotation. Sketch the figure on the graph. So we want to sketch it, describe the shape, so what's the name of it, and then we want to calculate the volume to the nearest tenth of a cubic unit. So here we have a rectangle. It says rotate about x equals -1. So let's find x equals -1. And that's right here. So it's one of the sides of your rectangle. So really visualize, if you guys have, they don't make them as much anymore, but like those little decorations, sometimes they're like a little centerpiece for a table that the kind of waffly tissue paper it looks like, and you pull the sides and then you paper clip them together, and it starts out flat, but it makes a circle. I don't know if you've seen those before, but that's kind of what we're doing, is we're taking something and we're holding an axis still, and we're spinning this shape around that axis as fast as we can go. So if I hold this still right here, that's going to stay. And then I'm going to swing this yellow rectangle around that axis and just keep spinning and spinning and spinning. And what will it create? Well, this side's going to go over 3 boxes to here. Will bring us to there. This side, as far as it can go on the other side of this axis, would be 3 boxes away. None of this side right here can go any further than this because we're holding that side still. So if we spin it, this side's going to go around to here, This side's going to go around to here. And we're going to have created a cylinder. So that's our sketch here of our cylinder. We've named it a cylinder, and we want to find the volume. So the volume of a cylinder is pi r squared h. So here our radius is going to be the width of the rectangle, which was 3 units. And the height will be this height of our rectangle, which if we count that up, should give us 7. So I've got the volume is pi times 3 squared times 7. So that's 9 times 7, 63 pi. And this asked us to round it to the nearest tenth of a cubic unit. So we're going to go to our calculator, type in 63 pi. It gives us approximately 197.9203372. Nearest tenth, our final answer would be 197.9. Let's try another one, number 2. So we're taking this right triangle and we're rotating it about y equals 2. So again, there's lots of different ways you could have rotated. They could have rotated about x equals -3 and spun it that way, or we're choosing y equals 2 right here. So we're going to hold this here. Actually, let me erase beyond. So we're holding this still right here. And we're going to spin this triangle around as fast as it can go. So this side over here is going to come over to here, and it's going to keep spinning from here to here and then back. This side is going to remain invariant. It's not going to change because we're holding that point still right there. So we're really going to go from here to here, and this is going to be spinning. And this point stays. So then let's just connect. And what have we created? Created a cone. So now we've sketched it, we've named it. Now we want to find the volume. So the volume of a cone is 1/3 pi r squared h. So our radius here is going to be this height of the triangle, which is 2 boxes. Our height of the entire cone will be the length of that entire triangle, which looks like it is 7 boxes again. So we want to take 1/3 pi. The radius is 2 squared, which is 4, times the height, 7. Multiply those together. So we'll get 4 times 7 is 28/3 pi, because 28 times 1/3 would be 28/3. Type that into our calculator. So 28 divided by 3 times pi, because we want to the nearest tenth, gives us 29.32153143. To the nearest tenth is 29.3. And that would be units cubed. Okay. And we are going to actually stop right there for those today. And I'm going to post a couple practice problems for you guys to do as well on some of these. Okay? I hope you guys have a great day. Stay healthy, stay strong, love math. Maybe do a math dance today. And hope to see you soon. Pie out.